Okay, we're gonna start talking about congruent triangles. Okay, so first of all, let me talk about what we mean with congruent. Let me write congruent. Now, congruent triangles are two triangles that look exactly the same shape, same size. So, matter of fact, we're gonna use a symbol. What we mean with same shape, we're gonna use this thing right here. We're gonna call that same shape. And same size, we're going to use an equal sign at the bottom. So when you guys see that symbol means congruent. Again, congruent means same shape, same size. Last unit, we were looking at constructions. Remember when you guys use sketchpad or straight line and compasses? There was one construction that I gave you guys that it said given three sides. So let's say I had this three sides, you guys might recall you guys had to construct a triangle given those three sides, right? Does that ring a bell? So you guys made a triangle. If I had given you the three sides, if I came by and I said each of you get the exact same three sides, all of you would have given me the exact same triangle. Now, some of your triangles might have looked like this, and then some others might have looked a little rotated. But at the end, they are the same triangle. Rotation doesn't matter. We're going to call it congruent as long as they have the same shape, same size. So there's going to be a few rules that are going to work. If I have two triangles, so let's say, let me move into a rule now, the rules that we're going to be using this time. Let's say I have two triangles. And I'm going to say they are congruent if the three sides of one triangle, so I'm going to mark the sides, so side one, side two, side three. The three sides of one triangle are equal to the three sides of the other triangle. Let's say this is side one, side two, side three. And we're going to call this side, side, side. The three sides of one triangle are equal to the three sides of the other triangle. Now, there's another rule. I'm going to have two triangles, and I'm going to say they are congruent if, now this one, the other rule we're going to use is, this is actually one of the constructions I gave you as well. I have two sides only, two sides of one triangle, and the included angle. Okay, so keep in mind, I use the word included angle. So it's not just any angle, it's the included angle. The included angle is basically the corner where these two sides meet. So it's going to be this corner. Notice how the two sides that I marked, they intersect, they meet at that included angle. So in the other triangle, again, I have two sides and the included angle. Notice I have two sides and the angle is right in between. So kind of like how the name says it, two sides and the angle in between. We're going to call that side angle side. Notice that for my letters, I'm using all capital letters. Side, 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 all three sides are congruent. All three sides of one triangle are equal to all three sides of the other. Side angle side, I have two sides and the included angle. Now there is one more rule. One more rule we're going to talk about, but let me show you guys something really cool. Let's say I have an angle. I'm going to call it angle B. I have a side. I'm going to call it side AB. And then I have another side. I'm going to call it side AD or DA. Now notice I have two sides and an angle, but it's not the included angle. So we can call this angle side side, or sometimes we can just call it side side angle. Now my question here is, given that angle, that side and the other side, can I construct only one triangle, or can I come out with more than one triangle? For congruency, I can only come out with one triangle. So let's see, for purpose, let me extend the segment BC. My point D, I can move it. The segment D8 is still 8.65. So as long as the side AD, the side BA, and angle B, as long as they don't change, I'm okay. My question again is, can I come out with more than one triangle? And let's see, I can come out with one triangle there. The dotted line, I just added it at the end so I could see the triangle. But the dotted line, I can always make it bigger or smaller. I don't have the measurement of that, so I could always make it bigger or smaller. Now, angle side-side or side-side angle will be a good rule if I cannot come up with another triangle. But let's see, let me move this side. What if I move it here? There's a triangle BAD. You guys see one triangle there? But if I have it here, you guys see my other triangle? So I came out with two different triangles. So I'm gonna say angle side-side or side-side angle does not work. That's not a good rule. However, let me take a look at an idea here. What if my angle is 90 degrees? So I have an angle, I have a side and a side. Because I have a 90 degrees, you learn this as a leg and a hypotenuse. You guys are familiar with the word hypotenuse. And let me create a dotted line. I see that I can create a triangle here on the right side. You guys see my triangle ABC. And if I move this C to the other side, if I move this point, I come out with a different triangle. The interesting part is these two triangles are the exact same size. They're just flipped. They're just flipped to each other. So angle side works as long as my angle is 90 degrees. But I'm given a hypotenuse and a leg, so I'm not going to call it angle side. I'm going to call it HL. There's a rule. Angle side does not prove congruency. So angle side does not work unless the angle is 90 degrees. But then we're going to call it HL, hypotenuse leg. So let's take a look at our homework. Let me add another rule here on our notes here. I'm going to say these two triangles are going to be congruent as long as I have this side and this side. So I'm going to say the angle side or side angle works, but then I'm not going to call it side angle. I'm going to call it HL. So side angle works only if it's a 90-degree angle. But again, I don't call it side angle. I call it HL. So let's take a look. Let me see. Those are the three rules that are going to work for today. Side angle side, or HL, hypotenuse leg. There are other rules that do work, but I'm not going to see those just yet. I'm just looking at these three for today. So determine if the two triangles are congruent. If they are, state how you know. So what do we see here? I see that three sides of one triangle are equal to the three sides of the other triangle. Didn't I just call that earlier side? So that's it. That's going to be my answer. By writing side, I am already stating they are congruent. How do I know? Because of side. This is all I'm going to ask you guys to type in. Do notice that my letters are capital letters. All right, let's take a look at question number 44. Before I move on, there's going to be two rules that we're going to use. One of them is going to be called reflexive. Let me write the word, reflexive. And the other one is called vertical angle. I'm going to use these rules sometimes. Now, what does reflexive mean? That is when I have two triangles that shared one side. Now, I'm going to say this side is the side, that side from the left triangle is equal to the side of the right triangle. When the two triangles share the same side, I'm going to say they're equal. So if I see a triangle that is reflexive, I'm going to be able to mark the side that they both share. This is the only way I can mark a side if it is reflexive. And again, reflexive, the two triangles are using the exact same side. Now, vertical angle, we learned before that vertical angle means that when there's an X formed, opposite angles are equal, right? We talked about this rule before, but we're going to see that as two triangles like that. When two triangles form an X, opposite angles are equal. That's the only way I can mark an angle that is not marked. So the only way I can mark a side is reflexive theorem. The only way I can mark an angle is the vertical angle theorem. So having that said, here number 44, I'm going to mark this side. I see the two triangles share that side. So right now, my focus is only on one triangle. Look at the markings. Look at the markings. I see two sides marked and one angle marked. I know every triangle has three sides and every triangle has three corners, right? Three angles. I'm not looking at how many sides there are because there's always three. I'm looking at what is marked, right? The sides are marked with slashes and the angles are marked with arcs. So I see there's two sides and one angle. So I'm gonna say based on on that triangle, I see there's two sides in the included angle, right? The angle in between. Side angle side is a rule that works. Quickly take a look at the other triangle. It should be marked the same way. If they are, then I'm gonna say those two triangles are congruent because of side angle side. Now let's take a look at number 45. I can mark this side. When two triangles share that side, I can mark it. I'm looking at this triangle here. Look at the markings. What I would recommend is always look at two of something, two sides or two angles. There's two of something that I marked, two sides or two angles. In this case, I marked two sides. And the angle. Let me ask you this: is the angle the included angle? Right? Is that 90-degree angle right where the two sides meet? If it is, put it in between the S's, a side angle side. But because this one is not, let me put the A at the side. Now, side angle does not quite work. I notice the other triangles marked the same way. Side angle does not work. That's not a good rule. It works only if the angle is 90 degrees, which in this case it is. But then I don't call it side angle. I'm going to call it HL. Cool. Now let's take a look at number 46. I can say that angle is 90 degrees, right? I see there's an X form, opposite angles are equal. Now my focus is only at this triangle. I see two sides marked. So let me put my two sides. Now I see an angle. My question is that the included angle? The included angle is basically the corner where the two sides that I have marked, if you want to let me highlight it, I have this side and this side. The included angle is basically where the two sides meet. In this case, yeah, that's what it is. So let me put the A in between. I quickly take a look at the other triangle. It is marked the same way. So side angle side works. Notice that my angle is 90 degrees. So don't think that every triangle where I see a 90-degree angle has to be HL. That's a problem that many people have. Number 45, yeah, it was HL. 90-degree angle gave me HL because that was side angle. But look at 46, there's a 90-degree angle, but it's not HL. All right, now looking at number 47, Remember, the only way I can mark a side is if the two triangles share it. The only way I can mark an angle is if the angles make an X. Neither of those cases happen here. Now, when I take a look at one triangle, I see that I have two sides marked, right? 1 and 2. Those are my only two markings that I have. So for beginning, let me write two sides. Now I need 3, right? Not 2. 2 is not enough. So this one doesn't quite work. I need 3. I don't have 3. So what I'm going to write, I'm going to call this not congruent. And yes, you will have to type in not congruent, the whole phrase. Notice that I only capitalize the end, right? In English, remember when you write a sentence, you capitalize the first letter. Same thing when you write words in math. When you write a sentence, when you write a phrase, in this case, capitalize the first letter, so not congruent. Unless they're names or abbreviation of things, then yeah, you gotta capitalize everything. Now let's take a look at number 48. Let me take a look at one triangle. I see there's two sides. So I will just begin with side to sides, right? But then I notice there's also one angle marked. Is the angle the included angle? I see this side and this side. They do meet at that corner. So yeah, it is the included angle. Let me put the angle in between. Now I'm gonna say I'm done. It is side angle side if the other triangles mark the same way. Now look at the other triangle. The angle that should be marked in order for the triangle to be side angle side, it should be this angle, not the one angle that is marked. Remember I said the two triangles have to be marked the same way. So it is not going to work. I'm gonna call this not congruent as well. So you guys are gonna practice. We're gonna work up, actually today we're gonna work up until 52. So I'm not quite done yet. You guys are gonna practice the 3 rules that we learned. Side, 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 side angle side, or HL. If it's neither of those 3, I'm gonna call it not congruent. So to see if you guys actually learned that idea, I'm gonna look at question number 49 through 52. State what additional information is required in order to know that the triangles are congruent for the reason given. So I want this triangle to be side angle side. From the 3 markings I'm supposed to have, right, 2 sides and the included angle, I'm missing one of them. My question here is, what am I missing? So to begin with, I can legally mark the side GH. I'm gonna mark it because the 2 triangles use that side. So based on reflexive theorem, I can mark that side. When I'm looking at my triangle here, I'm just gonna look at one triangle. My question is, what am I missing? I'm supposed to have 2 sides in the included angle. I have the 2 sides. I don't have the included angle. I'm missing this angle. Now, when it comes to angles, I can call it 1 letter or 3 letters. The only problem is that we can say I could call it just angle G. The only problem is that I cannot use the 1 letter if there are multiple corners at G. And yeah, there are multiple corners for G. So in this case, I cannot use 1 letter. I have to use 3 letters. So I'm going to call this angle FGH. So I have to use 3 letters. Cannot call it angle G because there are multiple corners at G. When you guys said G, if you guys were to say G, which G are you talking about? That one, this other one? Like, which one are you talking about? Okay, so there. Now on the other triangle, So I'm gonna say this is congruent to, what am I missing on the other triangle? I see the two sides and it has to be the included angle. It has to be this angle. Because there are multiple corners at H, I cannot use one letter. Have to use all three letters. So use all three letters of that triangle, leaving H in the middle. So GHW. Some of you might be, can I call that WHG? Or does it have to be GHW? However you want, as long as you use the three letters and leave the vertex in the center. Now for your homework, the congruent sign is going to be in there. You just have to complete the two statements, FGH and GHW. You will already have the congruent sign. We cannot type it. We don't have a way how to type it. So I'm going to include that on your homework. You just have to complete the statement. All right, let's take a look at number 51. I can legally, to begin with, I can legally mark the side KM because that side is used by both triangles. Let me highlight one of my triangles. I'm looking at this triangle. And this has to be done with side. So with this one, it said all three sides of one triangle are congruent to all three sides of the other triangle. So I know the congruent sign is going to be given on your homework. So my yellow triangle there, I'm supposed to have all three sides marked. My question is, which side am I missing, or which marking am I missing? Well, we can legally say, I'm missing this side. But when you type in your homework, you're going to say this or that. So we have to name that side, this side. When we name a side, we use two letters. Which are the two letters that make that side? I'm going to call this GM. If you call it MG, the order of the letters does not matter. Now, on the other triangle, which side are we missing? Well, I'm missing this side. So that's this side. I'm going to call that ML. If you call it LM, it's fine. When it comes to sides, we always use two letters. When we come to angles, it's either for angles, it's either one letter or three letters. If there's multiple corners at that letter, we have to use all three. So now here for 51, HL, I know HL is basically side angle. The angle has to be 90 degrees, which that's what it happens. Now to begin with, I'm gonna say this other angle right here is 90 because those two combined make it 180. So I can say that. Let me mark the side YZ because I have to have that one marked because it is used by both triangles. Remember, we use reflexive theorem. When a side is used by both triangles, we can say that side is congruent, right? Because it's used by both triangles. So I'm going to take a look at one triangle here. I'm taking a look at this triangle on the left. I'm supposed to have side angle. So not the included angle. Let's see. What if I came in and said, I'm missing this side? Will that be okay? That will be for side angle side, the included angle. But I don't want that. I'm going to say this one. This is the side that I'm missing. Right? I need a side angle, so not the included angle. I don't want my sides that I need. I don't want my sides to meet at the angle that I have. All right, so earlier I said when it comes to sides, I'm going to use two letters. So SY. Again, they're capital letters. This is congruent to, let's see, on this other triangle, do I need this side? That will give me this angle. No, that doesn't work. So it's not that side, it's this side. Remember, the angle, it's side angle, so the angle is not the included angle. Included angle is when the sides meet. I don't want it to be the included angle, so it's going to be the side YX. Take a look at question number 52. Let me mark this side because they both share it. And let me highlight one triangle. I'm looking at this triangle. It doesn't matter which triangle of the two you pick up first. Now, I want this to be side angle side. So 2 sides and the included angle. I'm missing one of my markings. I have the 2 sides already, so it seems like I'm missing this angle. It's not just any angle, it's the included angle. It's the angle where the 2 sides meet. You guys see this side, you see how they meet at that angle? So that's why I said is that angle. Now, sometimes I could call it angle X, just one letter, if there's only a unique corner X, but now there's multiple corners of X, so I cannot use one letter, I have to use all 3. So I'm gonna use all 3 letters of my triangle, leave X is in the center. So I'm gonna call this WXY, all capital letters, is congruent to, well, my other triangle, in this case, the white one, I'm missing this angle, right? Again, use all 3 letters, leave X or the vertex, leave X's in the center. So I'm gonna call this EXY. Now, some of you, can you call it YXE? Yeah, use all 3 letters, leave X in the center. The vertex goes in the center. So EXY or YXE, however you want. So for the first part of the homework, I'm going to ask you complete it. And for today, we only know 3 rules: side, 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 side angle, side, and HL, or not congruent. For the first part, just tell me they are congruent. For the second part, I want them to be congruent, but I'm missing one mark. What am I missing?